Hi everybody, hope you're doing well today. If you're watching this video, that means we're already at the end of week 3 of the 4th marking period for Algebra 2. This video is going to correspond to section 8.6 out of Unit 8, which is going to talk about the properties of logarithmic functions. So we're going to look at today how to take a logarithmic expression that has variables and figure out how to not only break them apart and to expand them, but also go the opposite way, how to take a broken apart logarithmic function and condense it back together. So we're going to look at a couple of properties of logarithms today and show you how that's done. So first thing we're going to look at here are the properties themselves. There are 3 major properties that you are going to use throughout this lesson and anything else that we do with this logarithm chapter. So we have what's called the product property, quotient property, and power property. Product property is this. If I'm taking the logarithm, it doesn't matter what the base is. That's an important thing with any of these functions. It doesn't matter if it's just a regular log, if it's log base 4, if it's log base 1 billion, if it's even natural log. All of these properties will hold true no matter what base your logarithmic function is. So going back to the product property itself, if I am finding the logarithm of 2 or more things that are multiplied together, so you could see log base b of m times n. You can break it apart by separating it using addition. So we know sometimes with exponent rules, multiplication and addition tend to go together. This is the same thing here. So I can take apart log base b of m times n and break it apart into log base b of m plus log base b of n. So if you see something multiplied like that, we're going to separate it using addition. The next property is the quotient property. Similar to exponents, if we see things with exponents being divided, we subtract the exponents. Kind of the same thing in the world of logarithms. If I'm taking the logarithm of m divided by n, the way that I separate it is by subtraction. So I would take the log of m minus the log of n. So it's always the top minus the bottom. It's always in that order no matter what values you're working with. Those first 2 functions, when it comes to expansion, are what you're going to want to look at first to separate that way. The last thing you're going to want to try to do in expansion is to look at the power property. So this is saying you have an exponent as part of your logarithmic function. So in this case, log base b of m to the n power. If you have an exponent as part of your function, basically you're going to take it out front of your log function and multiply it out front. So you can see I swing the exponent out front and it turns into whatever the exponent is times log base b of whatever I'm dealing with. That, when you're doing an expansion, you're going to do that last if that applies. So those are the 3 functions we're going to look at here. We're going to look at and see if we can break things apart. If we're multiplying, we break them apart using addition. If we're dividing, we're breaking things apart using subtraction. If we see any exponents along the way, at the end of breaking apart products and quotients, we're going to throw them out front and act as if they are multipliers of the log function. So we've got 4 examples here on the page. Let's take a look at how those apply. So in number 1, specifically example A, we have log of x squared y cubed. So I notice 2 things in this problem. I see 2 different variable terms that are right next to each other, which means they're being multiplied. So we're going to have to deal with that. And I also see exponents, which means we're going to have to deal with those as well. So again, when we're doing an expansion is going to mean we want as many logs as possible. So I want to break this apart as far as I can. Essentially think of it as if I'm expanding it apart, I'm trying to factor it apart into as many pieces as I possibly can. So if I have the option to choose between multiplication and powers first, I'm going to break apart the multiplication. So to do that, okay, you can think of it as having the little multiplication sign in between these. It means the same thing. I'm going to go ahead and split this apart into 2 separate log expressions. Log x squared. Since I'm splitting up multiplication, I'm going to use a plus sign. Log y cubed. That's the first thing I'm going to do to break this apart. Because again, multiplication becomes addition. Now, I still see powers with my terms that I have. So what I'm going to do with those powers is each one of them is going to come out in front of the log. So I'm going to rewrite this as 2 times log x plus 3 times log y. There's nothing more I can do with it, and that's my final answer. Most of these problems, you're going to have a couple of steps in which you'll expand everything. So again, all I'm doing is matching the properties from up top. I saw multiplication, I turned it, broke it apart using addition. I then look at the powers, throw them out front, move them, and they act as multipliers to the log function themselves, and that's it. That's how we expand. Log x squared y cubed is the same thing as 2 log x plus 3 log y. Reason why we do expansion, and we'll talk about condensing these functions here in a few minutes, the reason why we do that is sometimes it can be helpful with equation solving, which is what we'll get into with the lessons that you are going to learn next week. So there is a little bit of a purpose to why we're doing this, if there's anything at all to that. Let's go ahead and talk about b. So here we have that ln, which just means natural log, aka log base of e, that magical e number that we've learned in this chapter. Natural log of 5x over 4. Now, I will say this. In problems that have fractions, if we're trying to expand, the first thing you want to do is split the fraction apart. There's other things we can certainly do, but my recommendation is if you see a fraction, split it apart. So if we go back up to our properties, quotient property, we are going to split it up using subtraction. So I'm going to go ahead and rewrite this as the natural log of 5x minus the natural log of 4. Now, I take a look at that. There's no powers. However, we need to look carefully here at natural log of 5x. Keep in mind that 5x is the same thing as 5 times x, which means natural log of 5x can split apart. If this is being multiplied together with the 5 and the x, that means I can split this apart into addition. So I can turn that into natural log of 5 plus natural log of x. And then tack back on the subtraction of natural log of 4. So one thing you're going to have to look for is you try to expand these as much as possible. Even something as simple looking as 5x, that is technically being multiplied together. Something you've learned since probably before the days of pre-algebra. That will also split apart. So be careful in not finishing these problems too soon. You do want to make sure everything gets split apart as far as you humanly can. So our final expansion for that, natural log of 5 plus natural log of x minus natural log of 4. Means the same thing as what we started with. Now, just like all the other videos here, if you think you have kind of the gist of it, try example C, maybe try example D, see how far you can get with those. If they match up, awesome. If you want to just keep watching the explanation, be my guest. So, let's talk about C. We have log base 6 of 5x cubed over y. Again, first thing you want to do, if you see a fraction, let's make that broken apart. So, again, a fraction will break apart into subtraction. So I'm going to have log base 6 of 5x cubed minus log base 6 of y. Now, one other thing just to point out, again, I referenced this a few minutes ago at the start of the video. A, B, and C, you notice we had a log, a natural log, and a log base 6. Like I said at the beginning, it does not matter what type of log or base that you have. These properties are all exactly the same no matter what. The only thing is as you write stuff out, just make sure you're using the same log, you're using the same natural log. Whatever's written there, make sure that's carried through the whole way for consistency's sake, because it does have its own separate meaning if you decide to lose the base or change log to ln or vice versa. So again, here we are. We've broken these apart by subtraction. So I'm looking at this 5x cubed. So we broke apart the fraction. That's the first thing you want to try. Second thing you want to try is breaking apart anything that's multiplied. Well, I have 5x cubed. That is multiplied 5 times x cubed. So that'll break apart into log base 6 of 5 plus log base 6 of x cubed. And then we tack on the log base 6 of y that's being subtracted. So we had a fraction, broke it apart. We had a multiplication problem, broke it apart. Only thing to check for now are powers. So if I look at this, I see an x cubed, which means that needs to go out in front of the log that it's with. So my final expansion, log base 6 of 5 is going to stay the same. In the middle, I'm taking that exponent of 3 and putting it out front now. So it becomes 3 times log base 6 of x minus log base 6 of y. And that would be my final expansion. D, same idea. I see a fraction. That's the first thing I want to tackle. So log base 7 of 3x squared minus log base 7 of 5y cubed. Next thing I want to tackle is anything that's being multiplied together. So I see it in two different spots. I see 3 times x squared. I see 5 times y cubed. Those need to be broken apart by addition. So log base 7 of 3 plus log base 7 of x squared. Now, little detail to keep in mind. That minus sign affects that whole log expression after that. What that also means is it technically affects how I break this apart. So I would still break this apart as log base 7 of 5 plus log base 7 of y cubed. However, because we know subtraction's finicky, that subtraction has to apply to the whole thing. So what happens is I'm going to technically put parentheses around it for right now because the minus sign has to affect the whole way that it breaks apart. So ultimately we'll get some flipping of signs by the time we get to the end of this. So the last thing I want to do now is play with any powers. So I see a square that's going to come out in front, and I see a cube that's going to come out front. So my final answer, we'll start off with the first half of this. Log base 7 of 3 plus 2 log base 7 of x minus log base 7 of 5. So what I'm going to do now is apply this minus sign to both of these expressions, minus the 3 log base 7 of y. Not saying you'll ever really see that many of those, but again, if we want to be technically right, we're going to make sure that the signs and everything apply the way that they're supposed to. Most of what I would expect you to have to worry about at the most is going to be a problem like B or C, where you'll have to do a couple of things at once, but you won't have to worry about little details with signs like that. But that certainly can happen. So ultimately, that's how we expand logarithmic expressions. Basically, this is the order that you want to try to do things in. First thing, look for a fraction, break it apart by subtraction. Second thing, look for anything that's being multiplied, break it apart by addition. Last, look for anything that has a power, pull it out front, and make it look like it's multiplying it by the log function it's in. So that, I'd say, is your checklist 1, 2, 3 in that order. So that's how we expand. We're going to use the same properties to go backwards. If I have a whole bunch of log functions, I can go the other way and turn them into one singular logarithmic function. Now, the way that this technically works, they all have to be logs of the same base. You're not going to need to worry about getting logs of different bases and having to condense. That's just one extra thing that's not that important right now by any means. But if you have multiple log functions that have the exact same base, you can combine them back together, the opposite of what I just showed you over the course of the last 10 to 15 minutes. So, to expand, we did fractions first, then multiplication, then powers. That was to expand. If I want to condense and go backwards, then I'm going to go the other way. I'm going to look for powers first. Then I'm going to look for anything that's being added. So I'm going to write a little checklist here up at the top since I'm condensing. Okay, so the first thing I'm going to do is look for multiplication on the outside. And we'll turn that into a power. Then I'm going to look for addition, which will turn back to multiplication. And then I'm going to look for subtraction and turn that to division. So basically, I'm going backwards of what I just showed you on the last slide. Okay, so we're going to look for anything that's being multiplied out front of a log expression, and if we see anything, we'll turn that into a power. Then we're going to look for addition, combine those things to make them multiplication problems. Then we'll look at subtraction, if that exists still, and turn that into a division problem, and that'll put all of our functions together, so it becomes one log function. So, same thing here, we're going to look at 4 examples and see if we can work our way backwards to condense it down to one singular function. So, let's look at number 2. Let's look at example A. I have log 3 plus log 2 plus log x, or excuse me, plus x. That should say log x. That's a typo on my end. My apologies. Nothing like spotting that live while making the video. Not the point. Let's talk about how we put this together. So, first thing I'm looking for is anything out front of the log. I don't see any numbers out front of any logs. So that means there are no powers involved that we need to create. So step 1, check for that multiplication out front. We did, there's nothing there. Step 2, look for addition. So I see multiple things being added. Log 3, log 2, log x are all being added together. That means I can take whatever's after the logs here and multiply it together. So, since all things are being added, I can immediately crunch this down to one log function and multiply 3 times 2 times x. Now, most of you, I imagine, can do that pretty quickly in your head. That would turn into log 6x. There are no other operations left. It is condensed down to a single log, and you have now condensed it. So, again, we look for that using that checklist at the beginning. Okay, what we have written here in the top right, there was nothing multiplied out front, so there's no power. Everything's being added, which means all the values after the log are getting multiplied together. 3 times 2 times x becomes 6x. We can rewrite this as log of 6x. All done. No other operations, so there's nothing more to do. Let's go ahead and look at B and do the same thing. First thing I want to look for here, so I have 4 log base 2 of x minus log base 2 of 5. First thing I want to look for is anything being multiplied out front. Well, I see this 4 multiplied out front. That means I'm going to turn it into a power of the log that it's affecting. So I'm going to take that 4, put it back in as an exponent. So I have log base 2 of x to the 4th minus log base 2 of 5. So step 1, we had something multiplied out front. Cool. Now we make it an exponent. Step 2, look for addition. Well, you can look as hard as you want. I don't see any addition, which means whatever's left here is not going to multiply together. Now we go to step 3, look for subtraction. Ding, ding, ding. We see that right here in the middle. So the fact that we're subtracting these two things means it's going to turn into a division problem to condense it together. So I can now crunch this down to one log expression, so log base 2. The first term goes on the top. The second term goes on the bottom, always in that order. That's my final condensing. Log base 2 of x to the 4th over 5. That's going to be my final answer there. So like I always reference here, this is a good point if you want to try C and D. Hit pause, see if you match up with what I got. If you don't, follow along here and I'll walk you through these last 2. So, let's look at C. Natural log of 5 plus 2 times natural log of x minus natural log of 3. Again, step 1. Do I have anything multiplied out front? Yes, I do. I've got myself a 2 out front. So I'm going to swing that back in as an exponent and rewrite this as natural log of 5 plus natural log of x squared minus natural log of 3. Step 2, look for addition. Hey, look, I see addition right here. Natural log of 5 plus natural log of x squared. So what I'm going to do is multiply the 5 and the x squared together and condense it to natural log of 5x squared. And then pull down what's left. Final step, look for subtraction. Hey, look at that. I got some subtraction. So now I'm going to take the 2 terms that are here, turn it into a fraction. So my final answer would be the natural log of 5x squared over 3. And last but certainly not least, example D, 5 log base 4 of x plus 2 times log base 4 of y minus log base 4 of x. And once again, another little pesky typo there, my apologies for that. So, let's go ahead and put this together. So, we're going to take, again, what's being multiplied out front. Actually, we're going to fix one other thing in this, and again, I apologize for these live typos that I guess aren't so live. I'm going to actually fix this here and turn that into a z. Since I already have something with an x, there's really not much of a point in keeping it that way. So, let's go ahead and finish this off. So, first things first, let's go ahead and take care of anything multiplied out front. So, I've got the 5 out front and a 2 out front. So we're going to swing those both up into exponents. So I'll have log base 4 of x to the 5th plus log base 4 of y squared minus log base 4 of z. Second step, look for addition. Hey, look what I got there. I got some addition. We're going to condense those things together and turn them into multiplication. So x to the 5th times y squared. All I'm going to do is write this as log base 4 of x to the 5th, y squared, and then pull down the minus log base 4 of z. And finally, I have subtraction. We're going to turn this into division. So I'm going to go ahead and take the first grouping of things that I have, x to the 5th times y squared, and put it over z. So my final condensing will be log base 4 of x to the 5th times y squared, all over z. So that's how we condense. And following that little checklist will certainly help you in trying to keep things in order. Same thing with what we did with the expansion. I know I verbally gave that a few times, didn't exactly scribble that down. But if you want to go backwards a little bit in the video, write that down so when you're working on if you're doing the practice problems, you're doing the graded assignment, whatever, you have that conveniently in front of you, and that should hopefully make this pretty easy to figure out. So, like always, there's extra practice, the quote-unquote homework for 8-6. I would probably, again, try a couple of them, match them with the answer key. If you're getting the same answers that I did, awesome. If you're not, please get a hold of me and ask for help before you do the graded assignment. Graded assignment, same deal as always. Make sure you do that, do it in a timely manner. Upload it. If you make a whole bunch of mistakes, I'll get back to you and tell you to do it again. If it looks pretty good, we'll grade it as is. So, again, can't emphasize it enough, just like every time I post on Schoology. If you've got any questions on anything, please shoot me an email, shoot me a Schoology message. I have office hours again on Zoom every single day. Please take advantage of those. I'll be more than happy to help you out. Hope you, again, are doing well. Stay safe, stay healthy, and we will see you next time.